I wanted to take a minute today at the beginning of the podcast and say thank you to our sponsor, Huber Engineered Woods. Huber has actually been a sponsor of the podcast since 2020 when we decided to start this little endeavor. Without our sponsors, this content is probably not something that happens. But I think the best part about having Huber as a partner on this is it's an incredibly authentic alignment. Peter, Steve, and I all use Huber Woods. I've been using Advantech Subfloor for coming on probably 21 years now. I've been using Zip System and Zip System with the insulation on the back, the Zip R, since 2013. It's a system that I believe in. It's that systems approach where things play well together. They have design parameters that allow you to use their system for what you're working on. It works. Their tech support's there. Their knowledge is there. I've never had an issue with their product, and it's a great thing that they've decided to sponsor the podcast. So thank you, Huber Engineered Woods.
This episode of the Unbuilded Podcast. Start over. This episode of the Unbuilded Podcast is brought to you by Arcland Firepoint. Yes, Arcland Firepoint is a structural sheathing panel that has patented intumescent technology. Yes, that technology carries a Class A flame spread rating, and it's also rated for 1 and 2 hour building assemblies. Not only that, but it also is more than 50% beyond what the code requires for fire resistance. Yes, for more information, head on over to firepoint.arcland.com.
I'm Jake Bruton, and welcome back to the Unbuild It podcast. I'm joined today by Steve Basic.
Howdy.
And Peter Yost.
10-4.
And for those of you that are just listening, Peter saluted for some reason.
10-4 is really not a, hello. 10-4 is an acknowledgement of, answering an order. Go get this, 10-4.
I am so glad you're here.
And
just saying.
Mommy and Daddy are fighting. This is where we're starting today.
Maybe it was your 70s CB radio days. Yeah, that's a big 10-4.
I'm just so glad he said daddy rather than granddad.
Yosty Toasty or something. What was your handle? It's
his ham radio days.
Well, I will tell you, when I was a kid, I loved tractor trailer trucks, so I was dying to be Peterbilt. I wanted to be Peterbilt.
I learned recently from one of our neighbors is big into ham radio. I'm going on a ham radio tangent. And I learned that Joe Walsh of the Eagles apparently is a huge ham radio guy. And if you're a nerd in the ham radio community, it is a big deal if you've gotten to speak to Joe Walsh.
There's a whole world out there of ham radio folks.
I'm always amazed, in general, I'm always amazed that all of these little cultures that they don't seem to exist until you have an interest in it. And then you realize this is incredible. The amount of stuff that's attached to this one idea.
I started seeing antennas on my neighbor's houses more and more in the city after Aaron told me about.
And it's it's a technology that's old and hasn't changed a whole lot, and it's surviving.
Peter remembers it being invented.
Yeah. You probably remember the first antenna going up. Where was that? Arizona somewhere or something? Outside the parsonage?
Antennae.
Okay, we have an episode today that is driven by a couple questions. If you would like to send us questions, it's questions@unbuilditpodcast.com. And
can we tell them that we try to answer them temporarily in addition to doing here?
That is a fair point. So even though it might take us quite some time to answer them on the podcast, when they come in, they get answered via email, almost always by Peter. Steve and I try to not do it. We let the one that's mostly retired handle it. And so you do generally get a response quite quickly. So,
but the cool thing is you read them, and that helps us decide how to use them in the podcast.
So
what do you do?
Nothing. You sit here, look beautiful. I'm the aesthetics part of the equation.
I see.
If you would like to prove that right or wrong, you can now quit listening and go to Build Show Network and check out whether or not you think Steve is correct. Our first question today comes from Wes, Wes, W-E-S, in Bonners Ferry, Idaho. How would you thermally break a slab in Superior walls is the question. So do you have any tips for doing a thermally broken slab within a basement made with Superior walls? That's his question.
Buy two and just mirror them and put insulation in the middle.
I don't know if I follow what you're saying.
So Superior wall, buy a Superior wall.
So first of all, tell our listeners what Superior wall is in case they're unfamiliar.
Superior wall is a precast concrete foundation system.
Comes in panels.
It comes in panels, and then they bolt it together on site.
And the panel, as a segue to talking about slabs, at the bottom, it kind of balloons out to form a footing as part of the bottom of the panel.
Yeah. So it's a ribbed panel that has some, I know them as counterforts, which are the ribs. Counterforts. Yeah. That's like a lateral brace to a panel system. It's mostly used in civil engineering.
I don't know that term.
But like a buttress kind of.
Yeah.
It's a solid buttress to
I get credit to say I know the term, but I learned it from him. So I don't have a leg up on you here.
And they're pre-insulated, right? So they're already insulated to a decent level too. I think it's like R25 or something like that. They also have wood slats on some of the ends of the panels on the ribs.
On the face.
The end of the panel also comes with like a 2x if you wanted to integrate a interior wall to it. And they're part, I want to say I can't remember if it's 7,000 or 9,000 pound concrete. 7,000
PSI. Yeah.
Which makes it virtually waterproof.
Pores are so tiny, it's not capillary.
Yeah. But I mean, I'm kind of joking, but I'm not. I mean, if you want to put insulation in the middle, you put a Superior wall up, you glue insulation to it, and then get another Superior wall and put it inverted.
Sorry. You do a double Superior wall.
Double Superior wall. It costs you a lot of money to do it. But
yeah. You'd be paying for 2 foundation walls. That would be a waste.
But I mean, if you really want to thermally break it, then just frame a 2x4 wall on the inside.
So
at the slab,
he's talking about for a slab.
Oh,
so
at the slab.
You're talking about for a lab or for a wall. Sorry.
I didn't hear that at the slab. That is a challenging spot. So what we did on our last job,
you're using in Superior wall, you're using the slab to hold the wall in place at the base, right?
Yes, you're using the slab to provide restrictive movement of the bottom of the wall. Correct.
And at the bottom of the wall to interior, it does bulge out.
It does, yeah. And it's not a flat, it's like a tapered, right? But what they have is it's not, I wouldn't say it's an eye hook. There's a substantial wire that comes out and it creates a loop, and you snap a rebar into it and you pour the rebar in the slab. So that wire bar ties the wall to the slab.
I didn't know that. So that is the structural connection between the concrete
it's not
slab.
a whole lot.
No, but it's enough to connect the two.
The one we just did.
I didn't know that.
I haven't done one in a while. We're about to do another one here soon. But when we did, I think we did 10-foot walls, because the one thing I think is really great about Superior wall is to make them taller, the panels. The incremental cost is unbelievably small, right? I mean, obviously it costs some money, but if you're doing a foundation system, you say, hey, I want to go from 9-foot panels to 10-foot panels. It wasn't like another $20,000 on 400 feet of panel. It was probably like another $6,000 or $7,000. So that's pretty substantial.
The cost of getting them there in the first place is already
everything is pretty much already accounted for. It's just make a bigger panel and you get paid for the concrete, right? Because even like kind of casting it, I mean, obviously it's going to take a little longer, but it doesn't.
And the assembly doesn't take any longer. It's not the bulk of the
cost.
No.
It's
they have a crane, so the crane doesn't care if it's lifting.
Whereas on a job site with cast in place,
you might have really another day or so with the guys putting in. They have 10-foot forms,
right? Yeah, right.
Or do they have to rent them?
Or more placing of bar, everything.
Just a whole bunch of more. But what we did there was we brought rigid up to it, and then we used closed cell to connect the wall panel to the XPS below and had the wire kind of go through it and then poured the slab on top of it. It's only like 2 inches of closed cell, but
so you sprayed the inside of the Superior wall panel with closed cell spray foam?
No, the bottom down at the foot.
Oh, okay.
Right. So we have, because you bring the rigid up and then it's this like tapered foot. It's really weird to deal with. And so we brought the rigid to the edge of that and then just went in with like a 2-inch tapered piece of closed cell. They basically shot it, and you don't care because you're going to pour the slab up inside of that. So you could turn it up the wall and then you pour the concrete slab up against it. So basically you're cupping the perimeter of the slab with closed cell. But the wire, you can still run it through.
And that deep in the ground, we're not really. Another question is, how much do I need that thermal brick?
That deep in the ground only works on the sides that are that deep in the ground. If you have a walkout,
good point.
You might not be quote unquote that deep in the ground.
But you could do some other detail to deal with that rather than. But in the below grade portions, I'm not real. Steve and I often say that the reason you put R10 underneath the slab is as much for thermal comfort issues as it is for energy efficiency.
Yeah.
Okay. I have another way to deal with it. You and I have done multiple foundations where we pour the slab and then that same amount of insulation that we would have put below, we just put on top.
Yep.
And then we do 2 layers of subfloor that are glued and screwed together. And now we have a wood floor that is insulated and soft and doesn't have that cold feeling that you're going to get out of the concrete, even if it's insulated, the way concrete countertops or stone countertops feel cool. Now we have a floor that we can put hardwood on without it having to be some special engineered hardwood or anything like that. We can do whatever we want. And the only thing we've done is paid for. Now I get that I just was about to say the only thing we've done is just paid for 2 layers of expensive subfloor that are glued and screwed together. But now we have an insulated, fully insulated.
But it's also going against a space that's arguably like already paid for. Like you're putting in the foundation, whether I put a media room down there or I make it storage space, I'm paying for the same wall assembly and pretty much the general floor assembly. So I'm elevating it, but that I would consider that I'm finishing the basement. So that's part of the finishing, right?
That's a good. So this doesn't mention whether it's a finished basement or not, but if you up your game on the walls, you're more likely to treat that as a.
So if I'm building a house for $400 a foot and the foundation is $150 a foot, I put another $50 at that $150 a foot to elevate my foundation system. I'm still cheaper than the above grade space to put that in.
Right.
So yes, it costs money, but freaking everything costs money.
I think of it constantly as we have a really great, Steve designed my house. For those of you that don't know, our kitchen island's great. It's big enough that we can sit there as a family of 5 and eat dinner. I never want to sit there and eat dinner because I have poor manners. And I sit with my elbows on the table and that countertop's cold. I would much rather sit at the wood table and have poor manners and put my elbows on the table while I'm eating. And that's why I don't like having, even though I have exposed concrete floors in my house for aesthetic reasons, I would rather not have it, even if it's insulated, just because the way it emits the temperature back to you, stone or concrete, feels cooler.
It's always tricky when people first think about the fact that countertop is not colder than the wood table. No. It's the same temperature. It's the specific heat, its capacity to pull a lot of BTUs out of whatever it touches. It's funny. We had a granite countertop in our kitchen in Brattleboro, and that was one of the things in the winter I did not like having not my elbows in this case, but my forearms on that cold surface.
What's funny is the chairs at our dining room table are plastic, but the kitchen island has like cushion chairs. So whenever we sit at the kitchen or at the dining room, at the dining room table, my wife grabs a blanket off the couch and sits on it because she doesn't like the chairs in the dining room. It's
a good one.
Thermal issues at the Bruton household here.
Even though we have like the most comfortable house in the neighborhood, we both have things that I'm like, we could buy different chairs. And she's like, these chairs aren't that old.
Whatever happened to the days where we just simply tolerated a little? Like,
absolutely.
I remember growing
Good luck dealing with clients that just will tolerate.
Yeah. I mean, well, I do tell clients, I tell clients, like, solving for stupidity costs money is one of my lines. A little discipline will save you a lot of money, right? Because clients want to solve for every scenario
eventuality
exists. Well, we wanted to put a 10-foot Christmas tree in, so we need a double door out front. Maybe you just don't need that big a Christmas tree. I don't know.
Maybe you pull it in with the branches yielding.
Every kid's bedroom has to have a bathroom because my kids argue in the morning. Here's a thought. Maybe like give them a time frame or teach them not to argue.
The number of times
do we want to go to where a family of 11 children
in a parsonage
in one bathroom?
I've heard Steve say a little discipline goes a long way to a client on a call. And I was like, I wonder how this is going to go over.
Who the hell is this guy?
But it's true. It's like,
would it be okay if I talk about something related to superior walls as part of this? We got another question.
You realize it's our podcast. We can talk about whatever we want.
Okay. All right. We had a question quite a while back and I didn't answer it. I don't think we answered in the podcast because I didn't have a good answer to the person who asked it, which was, how do we know that the joints in the superior wall, how long till they leak?
Okay.
And I thought that my memory, because we did a research project at the NHB Research Center on superior walls, that the joint was a compression gasket, but it's not. It's a sealant, and it's a double bead. As they put the panels together, and I'm thinking, wow, I don't know if for a foundation, which you think would be a 100-year assembly, how long does the sealant last? And so there was a guy that you used for a project in your area, a really great guy who is a superior wall owner of a company or franchise. And we never took the conversation anywhere like, well, how, can you send me to projects that are now, because they've been doing superior walls since at least 1990.
I did at Building Science Corporation in Flint, Michigan. We did 2 houses. This is like 1998.
Yeah.
Long time ago.
It was before I was on board, so I don't know these projects.
Wall, yeah. And I remember like seeing them, and those were just 4 walls. Like the footprint was probably 24 by 32 or something. It was a 2-story small affordable housing demonstration project.
So it'd be cool if we could try to get some, even if it's just anecdotal information on, okay, these people in the house for 30 years.
I wonder what superior wall says.
I'm sure they have 30-year.
There are no 30-year sealants. I mean, the guarantees on sealants are 2025 for silicone. I don't know what kind of. We're gonna get a better answer.
But so this goes back to the whole where I want to do a podcast where we talk about things that we've seen versus things that we believe.
Yeah.
Right.
Yeah.
Because you say sealants they're only made to last 25 years. Well, that's what the company says. That's like saying an LVL is made to carry 96 pounds per linear foot. No, that LVL can probably carry 300 pounds per linear foot. The stated rating is 96 pounds per linear foot because they have to account for a whole bunch of other things that are happening.
I got you, but we're not talking about being off by 5 or 10 years. We're talking about being off by a factor of 4. If you want that superior wall to be a concrete foundation for 100 years, that sealant should be lasting for 100 years. And I just don't get that. But to be fair, I've never driven this far enough to get face to face with somebody from superior walls to have this discussion.
There's a couple things that happen on superior walls that I think are very cool. Like when we did ours, that whole thing the whole foundation is sitting on about a 12-inch stone bed.
Yeah, that is very cool.
So that relieves a lot of pressure against the wall because the water has someplace to go.
Yep.
And the whole reason on this project, pretty much why we did superior wall was because it's backed up against the hill. Water, when we excavated, water was seeping out the walls of the excavation. And we did the superior wall so that we could have the water literally go under the house and into the neighbor's
So you're
yard
starving the
downhill.
joint. You're starving the joint.
Exactly.
Interesting.
So
Okay.
part of their system, I believe, is that it's not seeing the pressure. Like if you do a traditional foundation and you put the footing on the dirt, you're basically, your excavation is kind of a boat,
Yeah.
right?
Yeah.
You put water in, it's that hard pan down below. The water isn't
Yep.
going to necessarily go in that fast. So you might get some elevated water table pressure against the foundation wall, all of that stuff, where if you have all stone underneath with a sump pump, that water rise is not there.
Well, I think I've called Superior Walls on this, and they've referred me to a franchisee. What we really need to do is stick with who's your lead tech person at Superior Walls.
Who makes the sealant too?
Good.
You should call them, and that could be a good resource. Hey,
You guys, you guys led me right into our next question, but
Cool.
before I read the question, excuse me, I'm going to start by telling a story that Pete and I were just discussing before we jumped on the podcast. The last house that my wife and I lived in was not a house that we had built for ourselves. It was a 1960s pit basement ranch. By pit basement, I mean not a walkout, no exterior access, just the 2 foot of foundation above grade where you have the little up high window that no one could ever
window.
actually get out of.
Peekaboo.
Yeah. And we'd lived there for, I don't know, 5 or 6 years. And then one Thursday evening, we were sitting up late watching a Mizzou football game. And my wife convinced me to put one more load of laundry in before we went to bed. And it had been raining during the entire football game. And I remember thinking, like, I can't believe they're still playing. Like, there was so much water on the field, on the University of Missouri's field in Columbia where we live. And I went downstairs and there was about a half an inch of water
Yikes.
in the basement. And we'd not had water in the basement before that. And so I spent like the entire night shop vacuuming up water, trying to keep it from
A half inch of water. What's the square footage of the basement?
That basement was about 1,000 square feet.
Yeah, that's a lot of water.
Like already there was a half an inch of water in there, and it had only been like 4 hours since we'd been down there. So it was coming in quick. So I was shop vacuuming water, taking it outside, dumping it.
Yeah, it's
which is probably not helping because it's just winding up on the ground, and the groundwater was what was getting down there. So by the time I got it all dry, the next day I went into a closet, cut the floor out, dug a sump pit, put a sump pump in, and there was still water coming in. And it was like, I would shop vac it up, dig a little bit, shop vac it up, dig it up. I put a sump pump in, plumbed it. And when I powered it up, it started pumping, and I went outside and it was running just fine. And I had dug in the trench so that it was kicking into the curb, like off my property, so that it wouldn't, no chance that it would run back in.
You're really voiding it out.
Yeah. It ran for 6 weeks without turning off. Like the water was dumping into that sump pit. And I was at work 6 weeks later, and my wife happened to be home. It was like a Saturday, and I was working, and I got a text message that said something's wrong with the sump pump. And so I was like, oh crap. Like
we're
the
going
water's
down.
Yeah. And so I literally stopped at the hardware store and bought
another pump,
a cheap one, thinking this will get me till Monday when the supply house opens back up and I can buy another Zoller sump pump. Not sponsored, but Zoller make good pumps. They make cast iron bodies. They make quality stuff. And I got home and I went downstairs and there was no water in the sump pit and the pump was turned off. And I reached down and lifted the float and it like kicked on. I was like, oh, there's nothing wrong with it. It's just not needing a pump.
Huh?
It never kicked on again. The next 6 years that we lived there, I never heard that thing run ever again.
That is.
I have no idea
why,
but it pumped out 6 weeks worth of water from underneath of our foundation that like, I couldn't tell what caused that event, but it never kicked on again. Now we did get a tiny bit of water at the other end of the house 2 or 3 years later, and I couldn't get it to stop coming in. And it was enough that it would run in and it would run across the concrete floor and into a floor drain. And to make it stop, I went to the outside, fixed a little crack. And then because I had dug all the way down to the footing by hand, I went ahead and put in a sump pump pit on the outside of the foundation
kidding.
moved that pump to the outside and just left the interior pump pit.
Interesting. Huh.
And so today's second question is about exterior sump pits. So that's why that came up in that
Do
conversation.
you have the address for that place?
Nope. I'm not giving my home address like you did in a podcast recently.
Well, it's not.
I don't live there anymore.
Yeah. Because I wanted to look it up on Web Soil Survey.
I'll tell you off the podcast.
Okay.
Okay. So the next question is from Pavel, Pavel.
Pavel.
Okay. Pavel. Love the podcast. Wish there were more to listen to. I'm starting building this fall in a relatively water prone section of the neighborhood. According to the soil survey,
Woo!
you're going to be happy. The water table is well below where my footings will be, but I still want to take all precautions to help mitigate water issues in the basement. Great. 2 questions about that. So let's address the first question. I've done some reading about exterior sumps, and they interest me. Boy, he's a dork just like us because that means there's no chance of backup or failure, which could lead to the pit flooding the basement. What are your thoughts on that? False. Like if you need the pump and it's not working, then it could let water into the house. It doesn't matter if it's outside or inside. Like, right? Like if you have a problem and the pump's there to solve it and the pump's not solving the problem, then you have a problem.
I've seen an article on how to detail it in a magazine years ago, and I always wanted
An
to
exterior
do one.
one. I've never seen.
And I haven't done one. The house we have under construction now, I use that detail to construct one on the inside. And I'll tell you why this one's different on the inside. But the one they constructed on the outside was a 24-inch corrugated pipe that they basically just backfilled when they backfilled along the foundation, and it has a cover on it. And so the sump pump is, 8 feet down into the ground. And
that corrugated pipe comes all the way up to
grade. All the way up to grade. So you'd have to go down. It might have been 30 inches in the detail or something, because you need to obviously get down in there or get lowered by your feet, right, to grab the sump pump to remove it.
So not exactly. You leave your piece of pipe on there and you lower the pump by the pipe.
Pump it up.
Got it.
Pull it up on the hose. But in the ground, the temperature down there, it's not going to freeze. So, yeah. But we have on a project right now, currently, we have a drop section of the basement that's 2 feet lower than the rest of the basement. So the question came up, how do we deal with that? Like, do we put in a second sump pump, or we put in a 24-inch corrugated pipe and we set the bottom elevation lower than the slab under the media section of the basement? And so that sump pump is serving the elevated portion and the lowered portion.
So we've done quite a few exterior sumps in our market, and that's exactly how he's describing it. You put the check valve down near the pump, and then you put your elbow to turn it up towards the top, and you put a fern co so that you can take it loose and lift the sucker out from up there. You don't have to get all the way down to service.
I grew up outside Baltimore, and it's just all this red clay. And everybody had a basement, everybody had a sump pump, but they were always on the interior. So is the main motivation to have it outside, just to take it out of your basement, basically?
Well, you don't have to deal with your cutting a hole in your foundation for radon.
So why wouldn't you never put one on the interior, since it makes more sense to put it on the exterior?
I would like to say there's some sense to this, but I've been asking this question for 30 years. Because I get some builders. My take is, if I could take it to daylight, it goes on the outside. If I have to pump it, I put it on the inside. That's my standard thinking. But I still have some builders that say, no, we always put it on the outside. And I'm like, well, where do you put the sump? Well, we put the sump pump on the inside. It just, the water will go underneath the stone or whatever. Like, it doesn't make sense, some of the thinking that.
So is it a provincial thing? Like in different areas of the U.S., we use Sidewinder hands instead of worm drive circular saws?
Yeah.
It's one of those type of things?
And when I put the one on the outside of my foundation, it was because there wasn't a place on the inside that I could put it where it wasn't going to be visible. It was living room / office with no wall between them. Where the water was coming in and where I could get access to it, it was going to be in the middle of the floor. And I already had a hole on the outside. And I was like, I bet I can solve this from the outside because my hole was getting water in it while I was in there fixing it.
And if you want to extend the controversy, then you talk about what kind of pipe do you use? Because there's the plastic perforated pipe that's, corrugated. People are like, that's crap. That's junk. I would never use that. It has to be a hard pipe. Some people with the hard pipe is like all holes or just half holes. So there's all kinds of personal thinking.
We use the corrugated pipe that they use for water meters, and then we use a water meter cap because then it's the cast cap with the water meter cap on it.
I like the corrugated because where we are, we can get it with a filter fabric sleeve on it. So it has basically a giant sock on it.
Yep.
To keep stuff from going inside.
So my brother lives in Boise, Idaho. And by the way, notice I said Boise, not Boise.
Is he a potato farmer?
Everybody who lives in Boise knows to say Boise, but other people, they do a hard S.
Boise.
Not hard ass, hard S.
Z. Boise or Boise.
He has a crawl space, which was wet. And so the guy said, oh, we'll put a sump pump in on an exterior sump pump. And they thought, okay, now we're in Idaho, climate zone at least 6, if not 7. And we're going to put a sump pump in that doesn't go below the frost line. That didn't make, that was
they actually, what do you think the frost line is in Boise? Because I'm doing a project just outside.
Boise. It's Boise.
Whatever.
See, how come I don't get to say whatever when I say read?
We don't give you any latitude.
Is it 60 inches?
No.
I mean, how deep is it?
Yes. Because we're doing a project there. I was astounded at what the number was when the builder told me.
We can look it up on the code map,
30 inches.
No, that's not possible.
There's really not a whole lot of moisture. To freeze the ground.
That's crazy. I wouldn't have thought that. It's that dry.
Because we're talking about like the foundation, and I'm like, I had the detail going down 40-80. He's like, we don't need to do that. We only need to go down, 30 inches. And I was like, really? And he's like, yeah, there's nothing to really freeze here.
Wow, that's super interesting. So the frost line is not just the factor of temperature; it's moisture content of the soil. I hate it when you school me on a soil thing. That just pisses me off.
Okay, so what we're going to say for exterior sump is like, if it works, it works.
Yeah, I think this is one.
If your drain tile is connected, if your footing is...
If everything's installed right, what do I care?
Yeah.
I think it comes down to the execution of the installation, not whether it's inside, outside, upside down, whatever.
Yeah, the water doesn't care.
Water doesn't care.
If it's just evacuating the water before it can cause a problem.
You learn something new.
I don't think it matters one bit.
You do.
So,
well, it's, you know what? You're supposed to surround yourself with very smart people, and then you find yourself learning stuff every day.
Yeah. I would normally say when I'm with two people, I'm not surrounded, but when it's you two, I am definitely surrounded.
Okay. His second question.
Wait a minute. Whoa.
No.
I've heard that the soil in the area, aren't the best, and they have settling problems. Wider footings are obviously a solution, but I'm wondering if laying a bed of gravel and then building the footings on top of the gravel could help spread the load and also serve as a small water reservoir. So how come Superior Wall does it, but we don't do it when we're building?
It's funny because I did it at my house because we dug the hole. The next day I went out, we had a foot of water in there. So we had
you have a really high water table.
Yes. So I had to buy like $1,000 worth of like 3-inch stone, and then we poured the foundation on it. But I think that is a good idea.
Expensive.
It's just the cost of putting it in. But
you think that's the only reason we don't do it?
I think so.
I bet you.
Well, yeah. And there becomes a code issue, or it's not so much a code. It's a, how do you regulate that the person putting in the stone, it's like compacted enough to carry, because the stone that's between the footings doesn't really matter anymore. It's only the stone underneath the footing that matters, and that needs to be installed. And what is its, pounds per square foot, bearing capacity, right? Relative to the ground that's undisturbed 8 feet down.
Right. Do you have to put rebar in a footing under certain conditions to give it more to get increase its bearing capacity?
We always put 2 bars in the bottom of it, 2 number 4s, and we just run it. And our footings are usually oversized. We just do a 12-inch or 24-inch by 12-inch footing. And I've asked our structural engineer, he said, Steve, you can probably do a 16-inch wide footing for a 2-foot. So you're already above. And understand the footing size is probably established like the LVL. It's based on like 2,500 pounds of bearing capacity, where you might have 8,000. Right. In some instances. So you're going to be way above, but they have to put what the least common denominator is for safety in there.
Yeah.
Right.
Interesting.
But in answer to his question, right, whenever you put something on stone, you're going to like this. I don't know if you know this. There's an angle called the angle of repose.
There's a very famous book called Angle of Repose.
Yes. And so it's basically 45 degrees. It's why like jack arches work, right? Same thing, same concept, but it's inverted. And so from the bottom of the footing, say the stone is 10 inches deep, and it's a 2-foot wide, let me do the math here. So it's a 24-inch wide footing on 10 inches of stone. That means your bearing capacity for that footing now is 44 inches.
Because
it's the 24 plus the angle of repose. So you get that benefit of 10 inches on each side.
What's really interesting about this is that the book Angle of Repose is about it as a geologic phenomenon. You're describing it as a structural phenomenon. Yeah.
What are the chances that he tries to put angle of repose as one of his resources? There's not a soul out there. Write in, tell me if you actually read the book Angle of Repose after Pete puts it as one of the resources, because he just stopped and wrote that down.
I'm embarrassed I can't remember the author, because Dan Cautley was the guy who's a mechanical engineer about this book. I cannot remember the author's name. But if there was any chance that I wasn't going to put this in, it's now gone because of what you said. You understand that.
Part of my job, if you're a new listener to the podcast, part of my job is to ask the questions to make sure that you two don't forget that everybody doesn't know everything that you know. And this may be a very simple one. I don't know the term jack arch. What is jack arch? And this is honest. I actually don't know that term.
When you rather than have a soldier course, you put the bricks on kind of a 40-degree angle. So it looks like a brick wedge.
Yep.
That's called a jack arch.
Okay.
So it's not it has
if you're listening, bottom. Steve did something with his hands that made that immediately apparent. So go and watch the video. I just have never heard that term jack arch before. Okay.
But I don't know if that answers his question fully, but you can get some credit of the ground.
Talk to your structural engineer. You could do that. It is possible. Bearing soil is a known factor. So that's why the engineering works for, if you do it on undisturbed soil, you're fine.
And in some places you have to, like if we do a project down here in Texas and stuff, that we actually get soil tests. So we know what the actual localized bearing capacity is, because you don't know what that is.
And the code says you can do that. You default to this, or you go and do something based on performance.
But in New England, my point is you could probably dig almost anywhere in Massachusetts and be relatively the same. In Texas, you could go 50 miles and it's like a different soil down here. So Colorado's the same too.
Awesome. Those were a couple really good questions.
Yeah.
So if you would like to send us questions, it's questions@unbuilditpodcast.com.
I have an obituary story before we go. Did you know the guy that invented throat lozenges passed away recently?
No.
There was no coffin at his funeral. And silence means success.
On an adjacent side note, not a joke, I want desperately to build my own coffin. And there's a weird, like, how long do you wait? And how many years do you have to like walk past that in your garage? Like,
so I'm going to tell you my perspective on this. There's something called human composting. And you put your body in to a steel container, and they put in just the right ingredients so that after 6 months, your soil, everything, your bones, your teeth.
You guys are thinking about it all wrong. See, I'm giving my cell phone to my best friend, and after my funeral, he's going to text everybody, thanks for coming.
You know, the most curious part about that for me is, who is your best friend? I haven't gotten your phone yet.
On that note, have a good day.
Bye-bye.
See ya.